All right, welcome. If you're just getting your career started in plant operations, you're probably seeing a ton of new heavy-duty equipment. Well, today, we're going to zero in on one of the most fundamental pieces you'll be responsible for, the industrial separator. So, you've made it through training, you've got the hard hat, and now you're standing in front of this wild network of pipes and vessels. Think of this as your field guide. We're going to walk through the core procedures so you can step up and take control with some real confidence. Let's dive in. Okay, first things first, what is this machine really? Well, at its heart, a separator is basically a pressurized tank that does exactly what it sounds like. It takes that raw mix of fluids coming straight from a well and uses stuff like gravity and pressure to split it all up into its main parts: oil, gas, and water. It's a totally critical first step for the whole operation. Now, you don't just, flip a switch on a beast like this. Bringing a separator online is a really careful, deliberate process. I like to think of it as waking up a sleeping giant. You've got to do it methodically, step by step, to make sure everything runs smoothly and, most importantly, safely. Before anything even thinks about flowing into that vessel, you've got a whole series of pre-flight checks. You're going to walk it down, double-check that all the drain and vent valves are shut tight, no surprises there. The vessel itself has to be purged, usually with nitrogen, to get all the oxygen out. You do not want oxygen mixing with hydrocarbons. Then you confirm all your instruments and safety systems are up and running. I mean, you wouldn't fly a plane with a dead instrument panel, right? Same deal here. Finally, you get it all lined up and punch in your initial controller settings. So once all that prep work is done, it's time. You slowly, and I mean slowly, start to introduce the well fluids. All your attention is on those pressure and level indicators. As they start climbing to where you want them, you start fine-tuning the controller set points for the gas, the oil, the water. And once everything's holding steady, you normalize your alarms, you install what's called the orifice plate. It's just a little piece of metal that helps us measure the gas flow, and you reset your counters. And just like that, you are officially online. But look, getting the separator running, that's just the beginning. Your real job as an operator is keeping it running safely and efficiently day in and day out. And that means doing your daily health checks. It's really about learning the personality of your machine, what normal sounds and feels like. So what does that actually look like? Well, you're out there making your rounds, right? You're checking the obvious stuff, pressure and temperature, but you're also doing a critical reality check. Does the level you see on your computer screen actually match what you can see with your own two eyes in the sight glass? Because if they don't, you've got a problem you need to figure out. You're listening for weird noises, looking for even the tiniest leaks, checking filter pressure. This isn't just ticking boxes on a checklist. This is how you build that gut feeling for what's right and what's wrong. And this quote just hits the nail on the head. You can read every single manual out there, but real, true confidence, that only comes from doing those daily checks, from seeing the little changes, from understanding the rhythm of your equipment. That hands-on experience is what's going to prepare you for the day things don't go according to plan. Which, brings us to that moment, the one every new operator is waiting for, with a little bit of dread and a little bit of excitement. An alarm goes off. That piercing sound. That's it. That's your first real test. This isn't about routine anymore. It's about figuring out what's wrong and what you're going to do about it. So let's run through a classic example straight out of the book. The panel starts flashing, the alarm is blaring, high-level trip. What this means is the system believes the liquid level inside that separator is dangerously high, and it's automatically shut everything down to stop it from overflowing. Okay, so in this moment, you've basically got two possible realities. Is this an actual, high level, a really serious situation where that vessel could overflow? Or is it a faulty alarm where a sensor is just crying wolf? Your very first job is to figure out which of those two worlds you're in, and fast. So what do? First, hit acknowledge on that alarm. Let's get some quiet so you can think. And you bypass the trip so you can get control of your panel back. Step 2, and this is the most important one, you go find the truth. You walk right over to the vessel and you compare the electronic reading on your screen to the physical liquid level in the sight glass. If that sight glass shows a totally normal level, you know your problem is probably the switch. You can then try to isolate it and drain it, see if that resets it. If it's still acting up, that's when you escalate. Time to call in the experts, the instrument techs. Now, just as important as starting up is shutting down. And this isn't a one-size-fits-all kind of thing. There's a huge difference between just stopping for a bit and doing a full takedown for maintenance. Mastering a controlled shutdown is an absolutely key operator skill. You can see it right here in this table. The two main types of shutdown are worlds apart. A normal shutdown is really just about diverting the flow somewhere else for a little while. But isolating for an inspection, that is a whole different ballgame. Because the goal there is to make that vessel safe enough for a human being to climb inside. And look at that isolation method row. You're not just closing valves, you're using things like double blocks and spades. We're talking physical steel plates to absolutely guarantee nothing can get into that vessel. It's a much, much more rigorous process that needs a whole stack of safety permits.
And that rigorous process we were just talking about, it involves 11 distinct, critical steps. That number isn't just a piece of trivia. It's a huge reminder of the layers of safety and the insane attention to detail you need before a person can enter what was a pressurized vessel. From locking out valves to verifying a zero-energy state, every single one of those 11 steps is completely non-negotiable.
So here it is, the big takeaway. Mastering these procedures, from the startup to the daily checks to the shutdown, it isn't just about following rules in a book. Every single check you do, every alarm you troubleshoot, it's a building block. It's how you build real-world competence. It's how you earn the confidence to call yourself a skilled operator. So, as we wrap this up, I'm going to leave you with a question to take out there with you. Now that you know all this, what's the very first thing you're going to check? I mean, really check on your next set of rounds. Give that some thought, because that's where your experience truly begins.